There's this hidden secret behind one of the most common shapes in the entire world, so today we're going to uncover the mathematical spine that gives the parabola its perfect, elegant balance.
Okay, so let me ask you this. What could possibly connect the wings of a butterfly, the massive arc of a suspension bridge, and a perfect three-point shot in basketball? It sounds like a riddle, right? But the answer is a simple, powerful idea our brains are just hardwired to appreciate. It's a principle of perfect balance.
Yep, you guessed it, symmetry. This idea of a perfect mirror image balance is exactly what makes a butterfly's wings so beautiful and a bridge's arch so incredibly strong. It's kind of like nature's and engineering's fundamental rule for harmony in design.
And that, of course, brings us to one of the most famous symmetrical shapes in all of math, the parabola. You know the one. That classic U-shape you see in everything from satellite dishes to the flight path of a ball. And this line has a name, of course. It's called the axis of symmetry. The easiest way to think about it is like a crease right down the middle of the shape. If you could just fold the parabola along this line, the two halves would match up perfectly, like a mirror image. And just look at this image. It's a perfect illustration. You can see how that vertical line just splits the U-shape clean in two. And notice how it passes through one single super important point called the vertex. That's either the absolute lowest point of the valley or the highest peak of the hill. It's the turning point of the whole curve.
Seriously, you can really think of this line as the parabola's spine. It gives it all of its structure, all of its balance, and what's really cool is that for every single point on one side of the curve, there's a matching partner at the exact same distance on the other side.
Okay, so here's the big question, right? How do we find this line with perfect precision without just kind of guessing by looking at a graph? Well, the answer is hiding in the algebra. There's a surprisingly simple formula that acts like a key to unlock the parabola's code. You see, pretty much every parabola you'll ever run into can be described by this standard equation. Think of it as the universal blueprint. And the secret we're looking for? It's hidden right there in plain sight, inside the values of A and B. And boom, here it is. This tiny little formula is our secret code. That's all it is. All you need are those A and B values from the equation, and you can instantly pinpoint the exact location of that line of symmetry. And using it is honestly so straightforward. It's just a few simple steps. First, you just grab your A and B from the equation. Then, you find the opposite of whatever B is. Next, you double A. And finally, you just divide. It's this elegant little process that just removes all the guesswork. It works every single time. This isn't just for finding some random line. No. This formula is an absolutely incredible graphing shortcut. It's more than just finding a line. It's probably the first and most important step to quickly and accurately sketching any parabola. All right, let's actually put this thing to work with a real example. We've got our equation, we've got our formula. Now we just got to plug in the numbers and see what happens. Okay, so let's break this down together. Looking at our equation, we can see A is 2 and B is 3. Simple enough? Now we just plug those into the formula. So x equals negative b, that's negative 3 divided by 2 times a, which is 2 times 2, or 4. And that gives us our answer. The axis of symmetry is the line x equals negative 3/4. Done. And this is the real magic right here, the big payoff. By finding the axis of symmetry, you've also found the x-coordinate of the vertex. This is the ultimate graphing shortcut. You've instantly located the x value of the most important point on the entire curve without even breaking a sweat. Okay, so this is cool for math class, but does it, matter in the real world? Absolutely. This concept pops up all over the place, especially in physics. Anytime an object is thrown or launched into the air, its path creates a parabola, and that means its whole journey has a hidden axis of symmetry. So picture this, a classic physics problem. A ball is thrown, and its path is perfectly described by this equation right here. How in the world do we figure out the exact moment it hits its peak? Well, you already know the answer, don't you? It's all about that axis of symmetry. The ball's highest point is the vertex of its parabolic path. And since we know the axis of symmetry always passes through the vertex, we just need to find that line. In this equation, the x value represents time. So, finding the axis of symmetry is going to give us the exact time the ball is at its highest. All right, let's use our formula one more time. From the equation, we can see a is -1 and b is 10. So, remember our secret code? x equals negative b, so that's negative 10, divided by 2 times a, which is 2 times negative 1, or negative 2. So what's negative 10 divided by negative 2? It's 5. And since x is time, that means the ball reaches its highest point at exactly 5 seconds. How cool is that?
So we've just seen how one simple formula can totally demystify the parabola, helping us graph it, and even predict the flight of a ball. We've found the parabola's spine. So the question I'll leave you with is this: what other incredible secrets and shortcuts are hiding in the math that shapes our entire world?